In this video, we're going to be going over logarithms. We're going to say that b and y are positive real numbers, but we're going to put the condition that b cannot be equal to 0. Then the logarithm y with base b is written as log with a base b, y is equal to x. And that can also be written as b to the x power is equal to y. So that is how we define a logarithm. So we have log b, y is equal to x. That should be b to the x power is equal to y. So we're going to change this log form into an exponential function. So we're going to rewrite it, and we're going to say log 2 16 is equal to 4. That means that your 2 is going to be your base. So we're going to rewrite this as 2 to the 4th power is going to be equal to 16. And we're just changing this based on the definition that we got. Once again, we're going to write this in exponential form. We're going to rewrite it as log base 1/4 4 is equal to -1. And when we rewrite this, it's going to be 1/4 to the -1 is equal to 4. And this is where we need to remember our properties of exponents. If we have a negative, if we were to flip this fraction, we'll get 4 is equal to 4. So we know that this expression is true. Now we're going to change this, and we're going to actually go into logarithmic form. So we're going to rewrite it. So we have 8 to the 2/3 power is equal to 4. So when we change it, we know that the 8 is going to be your base. So we're going to say log 8 of 4 is going to be equal to 2/3. A logarithm without a written base has always a base of 10. So if we have log 4, that is the same thing as saying log base 10, 4. Logarithm functions are inverses of exponential functions. That means that you're going to use exponential and logarithm functions to undo each other. For example 4, we're going to find the inverse of f of x is equal to 6 to the x power. And to do that, we're going to put it as y is equal to 6x. We're going to swap our x and y, so we're going to put x is equal to 6y. And now you're going to do log 6 on both sides. This cancels, and you're left with log 6x is equal to y. So that will be the inverse functions. So we know that that is the inverse of 6 to the x power. In math, people have discovered different numbers, and they have been special numbers such as pi and I. We know that pi is going to be an irrational number and I is going to be an imaginary number. Another number that it was very important that was discovered was e. Euler used a formula for compound interest to identify this number, and he was able to compute it to 23 decimal using the expression 1 plus 1 over x to the x power. Keep in mind that he did that without using a calculator. Now, logarithms with the base e are going to be written as ln, so that just means natural log. Now we're going to be going over properties of logarithm. The first one is going to be the product property. So if we have, and we're going to say that b is going to be the base, and you have m and n as two positive real numbers, and remember that b cannot be equal to 1. Whenever you're adding two logarithms, so if we were adding log base b, m plus log base b, n, that is the same thing as doing log base b, m times n. The quotient property is very similar, but in this case, instead of adding two logarithms, we're actually subtracting them. And anytime that you're going to be subtracting two logarithms with the same base, we are just going to divide m by n. This one is slightly different because you have a logarithm base b, you have m, and n is going to be the exponent of m. So whenever you have something like that, you're able to move the exponent and put it in the front, and this is going to be the power property. This is an example of when we can use those properties. So for part A, they're telling us to divide two logarithms. Now, if we don't have a calculator, but they're giving you what the value of each logarithm is, you're just going to apply that property. So we know that we have log base 2, 3/7. So we're going to just make this equal to 1.585 minus 2.807. So we're just applying the property. In the next one, they're telling us to find the logarithm base 2 of 21, but we don't have a calculator once again, so we can actually just rewrite this as log 2, and then this is 7 times 3, and we just use a property that we already know. That means that this is going to be equal to 2.807 plus 1.585. And in the last one, we know that we have log base 2, and 49 can be written as 7 to the second power. So we could actually rewrite this as 2 log 2 of 7, and that is going to be equal to 2 times 2.807. So we're just using those properties and we're just applying them based on the logarithm that we have. For this example, we're going to expand and condense an expression. So we are going to make sure that we're able to split this one, and we're going to do it in parts. We know that the operation between these two are multiplication, and we know that the x has an exponent, but only the x. And then we have a y that we're dividing by. So the first thing that we're going to need is going to be the product rule. So we have ln of 5 plus, and then we have ln of x to the 7th, and we have minus ln y. We still have an exponent right here, and we need to change it. So we're going to use the power rule now, and we're going to say ln 5 plus 7 ln x minus ln y. So that's how we're going to expand it. For the next one, we're going to condense it. So that means that these two are going to be adding, and we're going to be dividing this one. But But remember that this is going to be an exponent because it's in front of the logarithm. So we're going to write it as log base 10, even though we don't have a written 10. 9 times 2 to the third power divided by 3.